In this section, we're going to look at negative exponents. In order to complete this section, you need to know how to add, subtract, and multiply signed numbers, understand and be able to extend the addition property of equality for solving equations, and be able to apply rules of exponents, the product rule, the power rule, and products and quotients to powers. To start us off, let's go ahead and fill out the first three columns of these tables. We're going to look at positive exponents, which we've already discussed. So for instance, on the first table, 2 cubed, if we cube 2, we should end up with 8. 2 squared is 4. 2 to the first is 2. Similarly, if we look at our 3 column, or 3 row, we get 3 cubed is 27, 3 squared is 9, and 3 to the first is 3. We can do similar things with fractions. If we cube 1/4, we want to cube everything inside the parentheses, so we get 1 over 64. 1/4 squared is 1 over 16, and 1/4 to the first power is just 1/4. Now let's go ahead and see what we can do in order to get zero exponents and negative exponents. If you notice each table, what we are doing, for instance on the 2 and 3, is we are dividing by 2. To get from 8 to 4, we divide by 2. From 4 to 2, we divide by 2. And therefore, that's the pattern that we want to keep continuing. So 2 to the 0, if we divide by 2, we get 1. On our 3's, we can divide by 3 to get from 27 to 9. Divide by 3 to get from 9 to 3. And now if we divide by 3, 3 divided by 3 is 1. In the last example, what we want to do is similar to the other ones. We want to divide by 1/4. But remember that dividing by 1/4 is the same thing as multiplying by 4. So if you multiply 1 over 64 by 4, you get 1 over 16. 1 over 16, if you multiply by 4, you get 1 over 4. And now if we multiply 1 over 4 by 4, we get 1. We can continue these same patterns to get our negative exponents. So if we continue the pattern for the top, dividing by 2, you can also think of that as multiplying by 1/2. And dividing by 3 is the same thing as multiplying by 1/3. So if we use these to continue our pattern, 1 times 1/2 gives us 1/2. 1/2 times 1/2 gives us 1/4. And 1/4 times 1/2 gives us 1/8. For the 3 row, 1 times 1/3 gives us 1/3. 1/3 times 1/3 gives us 1/9. And 1/9 times 1/3 gives us 1 over 27. If we do our 1/4 row, again, we can either divide by 1/4 or multiply by 4. I'm going to go ahead and multiply by 4. 1 times 4 is 4. 4 times 4 is 16. And 16 times 4 is 64. And so now we have some things that we can look at. One of the first things that I want to point out, we want to look for some patterns that exist here, is notice that 2 to the first 2 to the negative 1. These are reciprocals. Same thing with 3 and 1/3. They are reciprocals. 1/4 and 4 are reciprocals. And so we see that throughout the table. If we look at 2 squared, 2 squared is 4. 2 to the negative 2 is 1/4. 9 and 1/9. 1/16 and 16. These are all reciprocals. Similarly, 8 and 1/8. 27 and 1/27. 1/64 and 64. So this is basically what we want to get from our negative exponents. Negative exponents are reciprocals. So that brings us to our rules about negative exponents. The first one that we have is anything raised to the negative 1 is the reciprocal. We have b to the 0 is equal to 1. And anything raised to the negative n, the negative takes the reciprocal, and then we apply the nth power. If it starts out as 1/b, same thing, we take the reciprocal to get b, and we still have our nth power. So some helpful hints that I want to provide you when working with negative exponents. When working with negative exponents, do problems in at least 2 steps. If you have an exponent of negative 2, take the reciprocal or flip the fraction and make the exponent positive. Then apply the exponents. Second thing, when working with negative numbers, note that a negative exponent does not affect the sign of the final answer. The sign will be determined on whether the exponent is even or odd. Also, remember your rules for when the negative is inside versus outside the parentheses. So let's go ahead and look at some examples. These are some very basic ones. If we start with example A, we have 7 to the negative 2. So the first thing that I want to do is, as I mentioned, I'm going to do this in 2 steps. I'm going to take care of the negative by flipping this. So I get 1/7 squared. I just want to move it to the denominator and make my exponent positive. From there we can evaluate the exponent, and we get 1/7 squared is 49. And we're done. Let's look at example B. Example B, we have 4 to the negative 3. And I'm going to do the same thing. I'm going to start by addressing the negative exponent. So I get 1/4 cubed. I move it to the bottom, make my exponent positive. From there, we can evaluate the exponent, and we get 1/4 cubed, which is 64. Okay, so now let's go ahead and talk about these negatives and what we need to remember with those. If we look at example C, we have negative 2 to the negative 4. And the negative 2 is inside parentheses, which means the whole exponent is acting on it. So my first step is, as I said, I'm going to go ahead and take care of my negative exponent first. This is going to equal 1/2, still in parentheses, raised to the 4th power. From there, we can evaluate the exponent. We have 1/2 to the 4th is 16, And since my exponent is even, it will become a positive 16. So now let's look at D and talk about the difference between these two. D, if we have negative 2 raised to the negative 4 without parentheses, remember that the exponent is not acting on the negative 2. This is essentially negative 1 times 2 to the negative 4. So I'm going to keep my negative, and I'm going to go ahead and flip my 2 to the negative 4 down to the bottom. So we get negative 1 over 2 to the 4th, which is equal to negative 1 over 16. Since the negative is not inside parentheses, it doesn't matter what our exponent is, it will remain negative. And our final example, example E, 5 raised to the negative 1. Well, since it's a negative 1, all we have to do is flip this, and we get 1 over 5. And 5 to the first is just 5, so we are done. So those are some basic computations with negative exponents. So now let's go ahead and start getting variables in the mix. Some helpful hints that I want you to keep in mind when we do this. When working with variables, the goal is to always write with positive exponents. So when working with negative exponents in a division, we can think of it as an extension of solving equations. Remember that when we moved terms to the other side, we changed the sign of the coefficient. So when moving to the other side of the division bar, you change the sign of the exponent. We want to pay special attention to what is inside or not inside parentheses, and how an exponent affects or doesn't affect each part of the problem. When working with exponents, there is a lot of flexibility in terms of what order you do the steps in. So on some of these problems that we're going to work through, I'll show you several methods that you can use in order to simplify the expressions. Alright, so let's go ahead and practice some of this. If we look at example E, we have negative exponents on the top and the bottom, and so the first thing I want to do is just move things across the division bar. 4 to the negative 3, I can move that down to the bottom and change my exponent to a positive. 5 to the negative 2, since it's on the bottom, I can move it to the top and make my exponent positive. And now we can go ahead and evaluate. So we get 25 over 64, and we're done. Now for example F, you can go ahead and distribute the exponent of negative 2. If we do that first, we get 3 to the negative 2 over 4 to the negative 2. From there, I would need to move them to the other side of the division bar, so we would get 3 squared goes down to the bottom, 4 squared goes to the top, and we get 16 over 9. Now, another method that you can use on this one is, remember, negative exponents are reciprocal exponents. So instead of distributing the exponent first, what I can do is take the reciprocal of the whole fraction and change my outside exponent to a positive. It does the same thing. From there, we can go ahead and square everything inside the parentheses, so we get 16 over 9. Now let's look at example G. For example G, one of the important things to know is, or one of the things that we want to look at, is what is being affected by the exponent negative 3. Since this is not inside parentheses, one of the key things to keep in mind is that it's just x being raised to the negative 3. So when we rewrite with positive exponents, it's only the x that is going to move, not the 4. So we are going to end up with x cubed, or 1x cubed, over 4. And that's all we can do with it. If we go to example H is a lot like example E. It's just a matter of moving things across the division bar. So x to the negative 5th, in order to rewrite with a positive exponent, we want to move it down to the bottom. Y to the negative 1, since it's on the bottom, we want to move it up to the top, and it becomes y to the 1st. Or remember that we can write that as just y. All right, that takes care of our examples for this section. Okay, so when are we going to see this again? Once we finish our discussion on negative exponents, we will go ahead and talk about scientific notation briefly. This is a notation that is used in science classes such as astronomy, biology, and chemistry, where you deal with very large numbers and very small numbers. Negative exponents come up when we talk about very small numbers. There are other applications of negative exponents that you will see when you get into higher math classes. You will talk about logarithms and exponential functions. And when you talk about those, you will also need to know your negative exponents.